working on, I don't know what section this is. 4.7, thank you. We are working on 4.7, which is completing the square. We did part of it yesterday. Okay, we did part of it yesterday. So tell me, if we did this yesterday, I want you to do it again and don't look at your notes, okay? If we didn't do it, good. So I want you to work this one problem. This is kind of for anybody who's just watching the video and missed yesterday's class, okay? Might help them out a little bit. So if I didn't ask you to do this problem, which I think I did, I want you to solve this problem by completing the square. Did we do this yesterday? Yes. Okay. So just see if you remember how to do it. Solve by completing the square. While you're working, I'm going to tell you one thing. On the test, if I tell you to solve it by completing the square and you solve it another way, I will not give you credit for it. Does everybody understand? Okay. I'm testing your completing the square ability, not whether you can solve it or not. You can. If you get a negative in the square root, what do you know is going to be in your answer? An I. Okay? So if you get one, just follow the rules that you learned in section 6, okay, and apply those rules. No, not negative I. Yeah, but when you do it, maybe a negative one. So that's there's a negative one. Yes? The plus or minus is what creates your two answers. That's okay. Okay, come on. Okay, all right, let's go, because some guys are okay and some guys are not okay. Okay, so the first thing you're supposed to do is what? Yeah, get that 1 over on the other side. We're going to leave a space, because what we're trying to create right here on this side is a perfect square trinomial. So the negative 1 goes on this side, all right? Now, what do we do? That's how you complete the square, guys. That's what it's called. What do you do to create a perfect square trinomial? Half of this x term, the coefficient of x, okay? Half of the coefficient of x, the b term is what they really call it. Half of b is what? 5, and then you square it, 25, and you add it right here. Now, you created a perfect square trinomial, but you also created a problem because you changed this problem, right? So what do I do to not change the problem? Yeah. Y'all listen, that's the rule you learned in Algebra 1, right? What you do to one side, you always do to the other side. Okay? Now, what are we going to do over here? We're going to write this perfect square trinomial as a binomial square. What's it going to be? It is always square root of the first, keep the sign, perfect, and square root of the last, 5, which should also be half of this number. Okay? Remember how we talked about checking that? Everybody okay? Alright, over here what's negative 1 and 25? Alright, now what am I going to do? Square root both sides? Okay, so now I get, what's the square root of x minus 5 quantity squared? Perfect. Over here, what should you write down first? Plus or minus. Thank you very much. Is there a perfect square that's a factor of 24? 4. So 4 times 6. What's the square root of 4? Where'd that 2 go? Where's the 6 stay? Thank you. Alright, now what do I do? Add 5 to both sides or move it over, whatever you want to say. Just think if you move it over that you change its sign. Okay? And so x is equal to, where does that always go? In the front. Put it in the front, put it in the back. Okay? So 5 plus or minus 2 square root of 6. Everybody remember that? When the radical's not in there. When you say, okay, here's what Amon's asking. Amon's asking, when do I get an answer? Like, remember yesterday we got 9 and negative 1. Okay? When did that happen? That happened when you didn't have a radical right here. This was a perfect square.
On our paper, it's kind of like that, right?
I don't know.
Did I say on the worksheet, learn it like 2 separate ones?
Yeah, okay, listen. This is 2 separate ones. It's 5 plus 2 square root of 6 and 5 minus 2 square root of 6. Okay, I'm okay with you writing it like that. Which way do I like it better? This one. Why? Because I can grade it faster. Okay, I don't have to look as much. It's not that big a deal, but either way. Then you're going to get 2 answers. Just 2 pretty answers. If it's not, it'll be, and this is called what kind of a number? This is a rational number. This is an irrational number. Anytime, remember how at the very first of the school year we defined rational and irrational. Irrational, when you take the square root of a non-perfect square, that's an irrational number. Okay? So you're doing that here. I don't care if you do multiply by 2 and add or subtract something. It doesn't make any difference. Still irrational. Okay? Yeah? That's all you can do. Alright, so now let's try a little real life problem. Are you ready? And while I'm doing this real life problem, I'm going to teach you something different. Okay? It's going to be like the last one on the worksheet, if you looked at your worksheet. Okay? So, I have a little rectangle right here. I know the length of this side is 7x, and I know the length of this side is x plus 6. Okay? I'm going to tell you that the area of this thing is 112, I'll say square meters. Okay? 112 square meters. I want you to find x. Okay? Find x. Okay? Alright, everybody paying attention to this one? Okay, put your worksheets up, guys. I want to see your worksheets. So, I want to know, do you know what to do? What? What do we do? Awesome. Okay? Here's what he says. 7x times x plus 6 equals 112. What did you use? What formula did you use? Area equals length times width. Okay? Area equals length times width. Now, I like the way he wrote it because that's the way we're accustomed to seeing it. Okay? So, 7x times length times width. Doesn't matter what you call what, people. Equals 112. Okay? Now, what am I going to do? Yeah, I'm going to distribute first. Okay? There's more than one way to work this problem, but I'm working it this way because I want to show you something. Alright? When I distribute the 7x, what do I end up with first? 7x squared, perfect. And then what? Plus 42x. And then I'm going to leave a space and do my 112. Okay, now what's different about this one than all the ones that we worked yesterday? Yeah. Did we do one yesterday? No? Okay. Y'all, you cannot complete the square unless this x squared has 1 as its coefficient. This is the way it's said mathematically. The coefficient of the quadratic term has to be 1 in order to complete the square. So it's all it means is x squared has to be a 1x squared. Okay?
What if you have like 9x squared and you said you want 3x?
Okay, well, you're gonna have to pull out that whole entire number. You're gonna have to pull out that whole entire number. So here's what we're gonna do. Now y'all, even if that 112 was on this side, I'm not gonna pull it out of the 112. I don't care about it. It's just a regular number, and I'm gonna move into the other side anyway. So what do I have to take out? Only a 7. That's all I gotta take out, people. What do you multiply? I'm factoring it out. What do you multiply 7 by to get 7x squared? What do you multiply 7 by to get 42x? Now I'm going to close that up. Now look, I want you to see something, because this is important. Did I change this problem in any way? I didn't change it. Now, here's something that's extremely important. Every time that you factor something out like that, you need to pull out a pen of a different color. Okay? A highlighter, something bright that's going to stand out. And you need to draw a rainbow from this number to this place. Okay? Every time you pull that out, you better draw that rainbow. If you don't, and there are 3 problems on the test, you'll make a mistake on one of them. That's exactly right. Okay? All right. So now we're going to complete the square in here. All this rainbow is, guys, is just a reminder. That's why I made it a different color, so it can stand out. If I make it in pencil, the same thing I'm writing with, will I see it when I'm working the problem? No, I should be working my problem. Okay? So now we are going to take half of 6, which is what? 3. Square it. 9. And I'm going to add 9 right here. But here's the question. Did you really add 9 to this side? You added 63. The distributive property, see, that's what I got to think about. That's what that rainbow is for, to remind me of that. I really added 63. So if I added 63 to this side, what else do I have to do? Add it to the other side. Now, why am I adding it to this side? What's the rule?
You do one to one side to the other.
That's exactly right. Whatever you do to one side, you have to do to the other. And that way you keep them equal and balanced, and you haven't changed it. All right. So now we're going to write this as a binomial square. Don't drop your 7. You keep him out there. Okay? And it's square root of the first. What's that? Keep the sign. Square root of the last. Quantity squared. This number can also be found by taking half of that. Over here, what's 112 plus 63? Now, y'all, this is just like the problems that we've been working. So what do I do? Divide by 7. So now I'm left with x plus 3, quantity squared, is equal to what? 25. Now what do I do? I'm going to read both sides. This is gone. Okay? That's x plus 3 is equal to what? Plus or minus 5. Okay? Now, here's that thing y'all were talking about. No. Don't do that. Don't do that. Okay, so let's subtract 3 from both sides. And x is equal to negative 3 plus or minus 5. Y'all don't go and do the 3 and then go to plus or minus. Okay?
Okay. I was subtracting 3, so negative 3 minus 5 is negative 8, and then negative 3 plus 5 is 2. That's what I meant. I didn't say 8. Okay.
All right. So you got 2 possible answers. Now, do you see when you get 2 possible answers, when you take the square root and you have what kind of a number? A perfect square, so that when you take a square root, that radical goes away. Okay? So, negative 3 plus 5 is what? 2. And negative 3 minus 5 is what? Now, what's my answer? What's my answer?
Negative 2 positive 8. What is that? No, it's x equals to negative 3 x equals to negative 8.
What does this x have to do with?
Oh, that is zeros.
What does it have to do with?
Oh.
Length and width.
It's
Oh, that come up when you do with real life stuff. You gotta be going, okay, wait a minute. That can't be negative. So the answer X is 2 is my only answer.
When you subtract the 3, you have to put that 3 in front so that when you have the plus or minus, you get the right answer.
Even if you didn't put it in front, watch what happens. But it looks, y'all, this is just not, it doesn't look good. Okay? It's like, eating your soup with a fork. Can you do it? Yeah, but it's not good manner. Okay, so what? Even if you put it at the back, it's still the same thing. What's a positive 5 minus 3? 2. What's a negative 5 minus 3? Negative 8. It's still going to be the same thing. It just doesn't look good. Looks like you're not a good mathematician. Okay? So, I mean, if you can't be smart, then what? Look smart. Come on. All right. Yeah, well, then you got some work to do. All right, anybody else got a question? No? Everybody okay? Okay, so we're going to practice this. Oh, we got to learn one other thing. All right, so here's our other thing we have to learn. What I told you I was going to tell you 2 ways to use completing the square. What was the first way? Solving equations. What was the second way? Put it in vertex form. Okay? Put it in vertex form. So let's talk about, anybody remember, without looking back. What did I say vertex form? What's that? A times X minus A, times square, perfect. Okay, and what's my vertex? HK. And you have to change the sign here and keep the sign here. Okay? Now listen to me. Changing the sign on the X makes all the sense in the world, because remember how we talked about graphing something, and if it's with an X, it is an X, and what does it do? The opposite of what you think it's going to do. People, that's what you're doing. You're taking the opposite sign. Okay? If it's not with an X, it's a Y, and he does just like you said. So you're going from this form, what's this one called? Standard form. Awesome. You're going from standard form to vertex form. Okay? So let me give you a problem. Now, I'm just gonna try to just work, because we only have a few minutes, so I'm gonna try to just work one problem, and I'm gonna apply a couple of things to it. Okay? Well, do I want to do that? Now let's just work a problem really quick. Y is equal to x squared minus 10x plus 22. And then we're going to do a real life problem. So I hope I don't work too fast. If I do, just say, whoa, whoa, whoa. All right? Because I'm doing stuff I like. So you know how when you get excited, you just back to that. All right, so here we go. Now, before, we would have put that 22 on this side, right? But I got a y over here. And what's the only thing that y can take its place? 0. So do I want to be putting anything over here with this y? Okay. So we're going to leave it as a y, and all I'm going to do is take that little 22 and just kind of ostracize him. I'm going to put him out there all by himself. Yeah, it's a plus. Did he change sides or anything? Okay, is this any different from this? Okay? No, it's all the same thing, isn't it? Okay, so what I want to do is I want to create a perfect square trinomial right here. Okay? So some of you are already going, oh, I know what she's fixing to do. So what is half of 10? 5 squared? 25. So I'm going to say plus 25. Now, did I create a perfect square trinomial? Yes. But did I change the problem? I changed the problem. Oh, Michael says, instead of adding it to the other side, because we said we can't do that, he says, hey man, if you added it right here, what can I do out here? Subtract it. Now, why am I doing opposite things here, whereas on the other one, I did the same thing? Yeah, this is on the same side, guys. Okay?
So we take from the 10 when we're helping it and making the third bit, would we take negative 5?
No, you don't, because I don't think about the sign, because when you square something, it doesn't matter if it's positive or negative, it's always going to be plus. Okay? Good question. Anybody else? Yeah. All right? So y is equal to, what am I going to write this as? People are trying to make it look like this. Okay? So I'm going to write it problem. Okay? So here we go. You know I love real life problems.
What is that?
Oh, thank you very much.
Yeah.
All right, so we're smacking a baseball, okay? Now, when you hit a baseball, that's where it hits. All right? So, when you hit a baseball, what kind of path does it take? Please, tell the two people what to make. A parabola. Okay, so he goes up here, makes a parabola, and then he comes back down. Everybody agree? We try not to make it really high and steep, right? You want to make it as straight out as you can, as flat as you can, but it does make a parabola. Okay, so here's what the question says. The height, this is example 7 in your book. The height, y. So y is the height of my baseball. In feet. Of a baseball, t seconds. So what's x going to be? Yeah, x is my time in seconds. T seconds after it is hit is given by this function. So they've given me the function. Look what it says. Y is equal to negative 16t squared. Uh-oh. Have we seen this before? Yeah. Negative 16t squared plus 96t plus 3. Find the maximum height.
But this has velocity.
Oh, find the maximum height. Now, what am I looking for, guys? If I want this maximum height, where is it going to occur? At its vertex. So, at its vertex. So, all I'm trying to do is find the vertex. Let's put it in vertex form, and then we can pop it out. Okay? All right. So, let's talk about this equation for just a second. What did I tell you this minus 16 had to do with? Gravity. Is that ever going to change? No, not unless you're on the moon. And we're not going to the moon tomorrow, you see. So, there it is, right there. What is this? This is velocity. In what? In what?
Second.
Is it in miles per hour?
Second.
Speed per second. That is in speed per second. Does that make sense? Okay? 96, that ball is traveling 96 feet per second. Is that fast? Yeah, pretty fast. Pretty fast. Okay? So, what is this 3 right here? It's a starting line. Does that make sense? Is that where that strike box is? 3 feet off the ground is that right in the middle, isn't it? Okay? Alright, so tell me what to do. We're going to complete the square to put it in vertex form. So, what do I have to do first? You gotta move that 3 over here, and then what else do I have to do? Yeah, y'all, you got not just a 16, but a negative 16. I gotta take out that net. Y'all, you can't complete the square on this until you take that negative 16 out. So, what do I multiply negative 16 by to get negative 16t squared? What do you multiply negative 16 by to get positive 96t? Okay? Now look at this. Because here's what you need to do when you're working problems. Have I changed that equation in any way? If I distributed that back through there, would I get this? Okay. So now we're going to complete the square. What's half of 6? What's 3 squared? So, what did I not do? I didn't draw the rainbow, guys. And listen to me. I'm telling you, if you don't draw the rainbow 1 in every 3 times, you'll forget. And you'll go, +9, +9. All right? So, there's my rainbow. Now, look, some of the kids got confused right here. Did you really add 9? You really did what? Subtracted 147. Okay? So, if I subtracted 140, isn't it? 144, sorry. So, 47 stuck in my head because that's the answer. Alright, so I subtracted 144. So, what do I have to do out here? You're on the same side. Add. sides. You gotta do the opposite when you're on the same side, okay? So if I subtracted 144 here, then I have to add it here. Now look, y'all are going, did we add and subtract right here? Did we do two opposite things? Did we do and undo?
Oh, yeah, 'cause you think you add, you gotta take it out.
Okay, do and undo. So same thing here. This is turned to negative, so what is it really doing? Yeah, that's negative 144, pardon me. So what's the opposite of negative 144?
Okay, got it. It is negative 16. If it is negative 16, if it wasn't negative 16.
If it was not, if this was a positive 16, what would I have done out here? Minus 1. Okay, make sense? Alright, so here we go. Y is equal to negative 16 times what? Quantity squared plus 147. What's the vertex? 3, 147. Okay, now I'm going to tell you what happened. Second period, when we pulled this negative out, I wrote a plus sign right here. Not one person in the class caught it until we got down here to the vertex, and when we pulled that out, it was a negative 3, and I said, uh-oh, we got a problem, okay? And so then I said, I made a mistake, and nobody caught it. So then they went back and found it, all right? So remember, this is a real-life problem. It's got to have a reasonable answer. Okay. Most of the time. All right, so here's my question. What is the maximum height? 147 feet. Okay? Here's my next question. When does it occur? This is time, and this is, okay? So 3 seconds after you hit it. So that outfielder, what's he got? 3 seconds, and that's at its peak, and it's starting to come down. You better move, people. You better move. And don't run up first. Just stand where you are and get your bearings, all right? So, everybody understand? Okay, good job, guys. Good job. Anybody got a question?
Actually, on the phone now.